So what we have here are three measurements that are measured with different degrees of precision. Okay? Somebody measured this on a balance that, assuming they did what they're supposed to do, measured only to the 10th of a gram. Okay? Somebody measured this one on a balance that went to 100th of a gram, like the balances, like the digital balances we have in here. Somebody here must have measured something on an analytical balance. Okay, one that will go to the thousandth of a gram. Okay, this is so sensitive you have to close it in. Just breathing on it makes it change. And even when you shut it off and have it nice and stable, it still moves around a little bit. So it's really, really, really sensitive. So the thing is, if this is only measured to this degree of precision, and this is only measured to this degree of precision, but this is measured to this degree of precision, our final answer is going to have some precision problems. Okay, let's add them up and see what I'll show you what I'm talking about here. So 12.4 grams NaCl, 0.47 grams of NaCl, and 123.478 grams of NaCl. .4 plus 0.47. Oop, I'll put an extra digit in there, my big fingers. Plus 123.478. Okay. 136.348. All right. If this first measurement had been measured on this measuring device, what would those numbers have been right there?
We don't know.
That's right. We don't know. And if this one had been measured on this device, we don't know what that number would be either, do we? So what we have are numbers, and we don't know what they're going to be. So we don't know what this answer should be, do we? Does that make sense? If you don't understand what I'm asking and asking you to think about, please tell me, because this is kind of important. All right? So since we don't know what this number should be, nor do we know what this number should be, these digits are no good to us. They're not real. Does that make sense? So we call them insignificant. Okay? These last two digits then are insignificant. All right? Now, in math class, you've been taught to put zeros there, right? As placeholders, haven't you? Maybe not in a recent math class, but somewhere in the past, because I know all my kids had to do that, right? Well, we can't do that, because when you put a zero there, you are saying that this measurement was measured on some device that would measure to the 100th of a gram, and that would be a lie. So we can't put zeros there. But sometimes it becomes kind of complex to keep up with all the slots and everything, keep everything lined up nice and neat. So if you need something to help you keep up with things and keep it nice and neat, an arrow is fine. Okay, but please don't put a zero there. I'll count it wrong because it's lying about the precision. Okay, your audience is a science teacher. A science teacher expects that to be indicative of the precision of the measurement. So if you don't tell them what they're expecting to know about that number, it is essentially a lie. Okay? Don't do it. All right? That makes sense? You with me so far? It doesn't make sense? Okay. Well.
It does.
Okay. Well, then let's just say don't do it. Okay?
I mean, I understand that.
Okay.
So would that 3 have to change to a 2?
No, this 3 hasn't changed. This 3 right here?
Yeah.
No. We're just going to round the numbers off the way you've always been taught to round. Okay? So if this were a 5, we'd round that up to a 4. But we're not going to do that. This is less than 5, so we're just going to take off those last two digits and we round it off. Does that make sense?
So they're insignificant, but you still add them into the problem.
You add them initially, but then you take them off at the end.
Okay.
You were asking, would that be a 2 because we're going to assume those 7s didn't exist? No, we still have to assume the 7s are there. It can't be less than that 14, right? It has to be at least that 14 or greater. So what we're going to do is we're going to use an arrow to show that we're rounding off. So just like an equal sign says this is the same as that as far as its value, this says this is not the same as that, but we're rounding it off. So you have to have an arrow, all right, because you have to communicate what you're doing. You can't use an equal sign. You can't use an equal sign with a slash through it because it's about equal or not equal to, or the squiggly equal sign because it's close to equal to. We want you to use an arrow to say that you're actually rounding off. That's the process you're following, okay? So we get 136.3 grams of NaCl. Okay, so that's our answer. That makes sense? In the sciences, it's really important that you are careful about how your measurements are all going together. Okay? Now, if we're doing multiple calculations to get a final answer, the best way to do that is to wait to the very end to round off everything. But then you got to go through every single step and make sure every single step was rounded properly and figure out what your final answer should be, and that becomes kind of complex. So for this class, for right now anyway, we're going to stick with just rounding off at each step anytime you do a calculation. Does that make sense? Okay, trying to keep it a little bit simpler for right now. All right? You take AP Chemistry, might have to move another step forward. All right? But right now, we're just going to round off at every step. Fair enough? All right. And in fact, near the end of the semester, we may practice a little bit with rounding at the very end of everything. Okay?
So you just keep the 4 and 8 and continue on. And
That's what you, yeah. What you would do is say, okay, well, this actually only had this many digits. Then on the next problem, you got to figure out, you got to round off based on the fact this really only had that many digits. And that's a lot to keep up with right now if you're just learning about significant digits. Make sense? So for right now, we're just going to do it this way every time you do a problem. Okay? Now, if you have a multi-step problem, that's a different thing. We'll talk about that later. All right? So you want to practice now? That's pretty simple, isn't it? Not hard, is it? Okay, I hope not. All right? So you practice now. Okay?